Hello everyone, welcome to grade 10. I think most of you know me. For those who don't, I'm Manal Yahya. I'm going to teach you mathematics for this year. This is our first online lecture. In this lecture, I'm going to make a revision for the important lessons that you have taken in grade 9, but I need in grade 10. Okay, so the first two lectures, this lecture and lecture 2, next week, they are going to be a revision for the important lessons that you might need in this year. Okay, so let us first start by listing the lessons that we are going actually to remember together in this lecture. The first lesson is inequality, so we are going to remember together what does an inequality mean. And that second lesson is powers and radicals or real numbers. First of all, the first lesson, which is inequalities. The objectives are to solve linear inequalities in one variable and to represent the solution as an interval. First of all, let us review inequalities. You know, when you see this symbol here, it means less than. So we say x is less than 5 as an example. So when I say x less than 5, x could be 4, 3, 2, 1, or the negative numbers. When I say greater than or strictly greater than, x is greater than -2, so all the numbers that are greater than -2, -1, for example, -1.5, it could be decimal also. But when I say less than or equal, it means it includes 3. So when I say x less than or equal 3, 3 is included in my interval. So when I count the numbers, I count 3. Greater than or equal to, or as you can see in this symbol, when I say x is greater than or equal to 0, the list of numbers are including 0 and above. So 0, 1, 2, and so on. So 1 is included in the interval. So pay attention whenever you have equal or you don't have. So if you don't have an equal, we say strictly less than. But when I have equal, I say less than or equal. Now, how can I graph the inequality? For example, suppose you have x less than 4. How can I graph this on an axis? You know that this axis is called an axis of abscissa. You know this from last year. But how can I distinguish between if I have x less than or x less than or equal to 4? You have to know that when I draw a circle which is not shaded inside, it means less than or greater than. So it is just enough to say that this circle, which is not shaded inside, okay, to represent that it's not equal. Or in another form, for example, you might see, suppose x is less than 3, so you can put a dotted line like this, okay, and this is x less than 3. So there are two ways to graph or to represent the inequality. Either you use circles or dotted line. If it is equal, you just make it straight. Okay, so both of them are correct. Either you use the dotted line or the circle, both of them are accepted. So the dotted line is the same as the circle, which is empty inside. It means strictly less than or strictly greater than. But if you have or equal, then you have to color the circle, okay, or use a straight line like this. That means or equal, okay. So strictly you use dotted line, but or equal you have to use a straight line. We are going to make a lot of examples, but for now I'm just going to explain the steps, okay. Let us continue. So Suppose you have this example. We need to write the inequality and graph them. Okay, let us take the first example. Suppose the statement is the summer temperature, which is T, in Phoenix is greater than or equal to 80 degrees. So the keywords are greater than or equal to 80 degrees. So that's how we symbolize the inequality. It's T greater than or equal 80 degrees. And as you see on the axis of abscissa, we draw a circle which is filled because we have or equal, so greater than 80, so all the numbers that are greater than 80. Another way to represent this value, you can put, for example, 80 and a straight line like this and greater than 80. This indicates that 80 is included. Okay, so both of them are accepted. Let us take another example. The average snowfall is less than 1 inch. When I say less than, it's strictly less, which means in 1 inch is not included. So that's how we represent it. The snowfall is strictly less than 1. So we don't have or equal. That's why if you look at the circle here, it's empty from inside because 1 is not included in my interval. And less than means all the numbers that are less than 1. So as you can see, it goes to the left side. Okay, you can represent it in another way. This is 1 and you draw a dotted line like this and you go to the left. Both of them, as I told you, are accepted. The third example, I advise you now to pause this video, try to make this example, and whenever you are done, play again the video to check your answer. Okay, so the class average is greater than or equal to 85%. So this is this statement, you have the keyword which is greater than or equal to 85. So that's how we represent. A is greater than, as you can see, or equal to 85%. So 85 and above. So we go to the right side and the circle is filled because we have or equal. Okay, and another way to symbolize this, you just put 85 and a straight line going to the right side. I wish you understood how do we write a statement or how do we represent it on an axis. Now, tips to solve linear inequalities. In the previous examples, the statement was very easy. For example, x is greater than 2, x is less than 4. But what if it is not organized, or in another word, the x is not on a side and the numbers on a side? So if you still remember how do we solve equations, actually we bring the unknown to the left side or to the right side and the numbers to the other side. So they should be separated by the equal. The same thing you are going to do in the inequality. So the steps to do this inequality is to just solve as if you are solving an equation where you put the variables on a side and the constants or the numbers on the other side. But you have to remember, if you multiply or divide by a negative number, then the sign will be changed. So you have to reverse the inequality symbol. If it's greater than or equal, it becomes less than. If it's less than, it becomes greater than. When you do this, when you divide or multiply by a negative number only. I'm going to do a lot of examples about this, but you have to keep those steps in your mind. So you just solve as an equation, you get the variable alone on one side, and in case you multiplied or divide by a negative number, you have to reverse the inequality symbol. Now let us solve this example. So as I told you, we are going now to solve this linear inequality. As you can see, we have a variable and numbers. Keep in mind the first step is to take the variables into one side and the numbers into other side. So I'm going to move the 3 to the right side as if you are solving an equality. When you move a number to the other side, If it's positive, it becomes negative, and if it's negative, it becomes positive. So it becomes 2x greater than 4 minus 3, then 2x is greater than 1, and now you divide both terms by 2. So you are dividing by a positive number, so everything remains the same. So x is greater than 1 over 2. Now, after solving, we have to represent this value on a graph. So, first of all, you put the axis. Half is between 0 and 1, and as you can see, it's an open circle because we don't have or equal. It's strictly greater than 1 over 2, and you go the arrow to the right side because it's all the positive numbers. Another way, as I told you before, to graph this solution is to put the axis. This is half. Suppose that half is here. You put a dotted line and you go to the right side. Okay, so both of them are correct. Now, another example, we have 3 minus x is greater than or equal to 9. So, the first step, keep in mind that you have to put the variables on a side and the numbers on the other side, and pretend that it's an equality. So minus x is greater than 6, because if you take the 3 to the other side, it becomes minus 3, and 9 minus 3 is 6. Now, it's very important to pay attention. We have minus x, and I want to get rid of this minus. Okay, as if you are trying to multiply the whole inequality by minus. Why I'm trying to do this? Because I need to get rid of this minus. So I need it as an x and not minus x. When you multiply by minus, as I told you before, you have to pay attention that the symbol will be reversed to the other side. So if it is greater than or equal, it becomes less than or equal. So when I do this, it's when I need to multiply by minus only. Okay, so if you go back to the previous example, we didn't have minus beside the x. That's why we continued normally. But in this case, when you have minus x and you need to get rid of this minus and you multiply the whole equation by minus, the symbol will be reversed. So as you can see, it becomes x less than or equal minus 6. Now, after solving, we need to graph this solution on the axis of abscissa. So x is less than or equal minus 6. The circle is filled because minus 6 is included in my interval. And now the last example, x plus 3 is less than or equal to 2 into x minus 4. So as I told you, just pretend that it's an equation and you are trying to solve it. So x plus 3 is less than or equal to x minus 8. So I'm expanding in this way. The x should go to a side and the numbers to the other side. So x minus 2x is less than minus 8 minus 3. And now x minus 2x is minus x. Minus 8 minus 3 is minus 11. And in this case, because I have minus x, I need to multiply the whole inequality by minus. So it becomes minus x, it becomes x. The symbol should be reversed. And minus 11 also, it becomes 11 because minus 11 times minus is 11. So it becomes in this way, x greater than or equal to 11. So the symbol is reversed. Why? Because we multiplied by a negative number. Please pay attention to this. I'm just repeating several times because this is a common mistake for all students. So most of you, they forget when they multiply or divide by a negative number, they just forget to reverse the symbol, and the whole answer will be changed. It will be completely different, because when you say x greater than 11, it's not the same when you say x is less than 11. So it changes the whole answer. So please, this is one of the important tricks, okay, because it's a common mistake between all students. That's why I'm trying to repeat several times. If you just get this, that's perfect, okay? Now the only thing which is left is to represent this on a graph. So as you can see, 11 is included because we have or equal, so it's a circle, complete circle, which is filled, and the values are everything to the right, because x is greater than 11. If you didn't reverse the sign, then you will get a different different arrow, different direction. So please, this is very important, okay? So to know this. That was everything about inequalities. And now I'm going to start by the second chapter, which is real numbers. Guys, please, this is a very important lecture, because later on when I explain for you a new lesson, I need you to know these, okay? So I just want you to those are basics. I don't need to go through all the things that you have taken, but those are very important, at least for semester 1. Of course, when I start semester 2, I'm going to make a revision for the things that I need, but for semester 1, it's just enough to revise these. So please pretend that this is the last chance to study them, okay? They are very easy. You already took these last year, but we are trying together to remember them, okay? Of course, you can keep your questions for the live session tomorrow, okay? But it's very important to watch the video at least 2 times, okay? Now let us continue about radicals. The objectives are to simplify the radicals. How can I add or subtract, multiply or divide radicals? First of all, you need to know that when I say a radical or square root, the positive square root is noted as radical A, and the negative square root is noted as minus radical A. So, but you have to keep in mind that radicals can never have negative number inside. So radical minus 2, for example, it's impossible, but minus radical 2, it's acceptable. Okay, for an example, radical 49 is 7, but minus radical 4 is minus 2. If you have, for example, radical minus 4, this is impossible. It doesn't work out, okay? So, the positive square root is radical A, and the negative square root is noted as minus radical A. In this chapter, I want you, every time you see, as you can see in the example below, x, you just pretend that x is a positive number, okay? You know, when I say, for example, a variable x could be positive or negative. But just in this lecture, I'm just assume that every time you see a variable, it's positive. I don't want every time to tell you that, okay guys, you know that x is greater than or equal 0, which is a positive number. So just pretend every time you see a variable that it's a positive number, okay? If you look at this example, radical 64x to the power 10 is 8x to the power 5. So 64 is treated as number and x to the power 10 as a variable. So radical 64 is 8 and radical x to the power 10 is x to the power 5. Or the square root of x to the power 10 is x to the power 5. Now let us explain the product rule for radicals, or how can I multiply two radicals. Suppose we have radical A and radical B are in numbers. So as I told you before, just pretend that A and B are positive numbers. Okay, only positive numbers. I'm not going to write the condition every time. I told you in this lecture, every time you see a variable, you just assume that it's a positive number. You have to know that radical AB is radical A times radical B. So if you have radical A times radical B, you just put them under one radical multiplied by themselves, okay? And radical A over radical B. So this is a fraction. You can split the radical to the numerator and the denominator. So if you have radical 2 over radical 3, for example, you put it 2 over 3 as a fraction and the radical 2 over 3. I'm going anyway to give you examples. If you have radical 40, you can just write it that it's radical 4 times radical 10. So you can split this number. So radical 40 is radical 4 times radical 10. And you know that radical 4 is 2 and radical 10 is radical 10. Now, radical 5 over 16, I told you can split the radical to the numerator and the denominator, so it becomes radical 5 over radical 16. Radical 5, it stays radical 5 because 5 is a prime number, and radical 16 is 4, so it becomes radical 5 over 4. Now simplifying radicals. Let us take an example. Suppose you have radical x to the power 7, and I ask you to simplify the following radical expressions. So radical x to the power 7 is written as radical x to the power 6 times x. Why? Because you know from the power rule that am times an, it's am plus n. So here, as if you have here 1. So just a minute, this is 1. So suppose you don't have radical x to the power 7, radical x to the power 6 times radical x to the power 1, it's am times an. And you know that, just a quick revision, maybe you have forgotten this, it's am times an, it's am plus n, okay? So now I did the opposite. I already have 7 and I write it in 2, 6 plus 1, so one even and the other is odd. Why did I do this? Because now x to the power 6, we can remove it from the radical. I can remove it outside the radical. It becomes x to the power 3 radical x. So what did I do now is I splitted the radical as radical x to the power 6 times radical x. Of course, you can do this without those steps, but I'm just trying to explain for you why do we do this. Why do we do this? Because I can split the radical as a multiplication, as you can see. So the radical x to the power 6, as you can see, we put it outside the radical as x to the power 3 because it's an even power. So everything which is even, you can put it outside the radical, and radical x, it stays as it is because it's an odd power. Okay, another example, radical 20 over x to the power 16. As I told you, you can split the radical into for the numerator and the denominator as follows. So it becomes radical 20 over radical x to the power 16. Now try to think of two numbers. You multiply them, you get 20. So it's 4 times 5. And or you can put 2 times 10. Both of them are correct. But I just write them 4 times 5 because the 4 I can put it outside the radical directly. X to the power 16, it's already an even power, so no need to split it, okay? Radical 20, it's radical 4 times radical 5. Radical x to the power 16, you could put it directly x to the power 8 because it's an even power. Now, radical 4, it's written as 2 radical 5 over x to the power 8. Okay, so that's how we simplify radicals. Another example for multiplying and divide or simplifying radical expressions. Suppose you have a radical 3y times radical 5x. And I need, as we learned, we need to put them under one radical. So you multiply the coefficients together and the variables together. So you multiply 3 times 5 and alone and x times y alone. Okay, so it becomes radical 15xy. Okay, so you multiply the numbers together and the variables together. If I have radical a to the power 7 b to the power 6 over radical a to the power 3 b to the power 2 or b squared, what do you do? As we learned, we split them. We split the multiplication, so it becomes radical a to the power 7 times radical b to the power 6 over radical a to the power 3 times radical b to the power 2, as you can see. Okay, or you can simplify. Pay attention. What we did right now is a to the power 7 simplified by a to the power 3, we get a to the power 4. Why? Because you learned before the powers rule, am over an. If you have this, you just subtract the powers, so it becomes am minus n. Okay? And also b to the power 6 over b to the power 2, we simplified them. It becomes b to the power 4. And now we have radical a to the power 4, b to the power 4. It becomes a squared, b squared. So guys, please, just to highlight things, you have here two ways to solve. Either you split the radical and solve each one alone, or you just put them under one radical and you simplify to the simplest form in order to get rid of the radical. So you have actually two ways to solve. It's up to you, of course. Both of them are accepted. Both of them will lead you to the same answer. So either you simplify, then you solve under the radical, or you solve under the radical, then you simplify. Both of them will lead you to the same answer. So till now we have learned how can I multiply or divide radicals according to the product rule. We still need to explain how can I add or subtract radicals. Okay, and you have here to pay attention very well, because rules in the multiplication or division, they don't apply in the addition and subtraction. In the multiplication, if I have radical a times radical b, we can put it under the same radical and multiply them. In addition or in subtraction, this will not work out. We cannot split sums or differences. We can only split the multiplication and the division, but we cannot split them in addition and subtraction. Please, this is very important. For example, if I have radical a plus b, we cannot split it as radical a alone and radical b alone separated by an addition. The same thing goes for the subtraction. If you have radical a minus b, you cannot split the radical as radical a minus radical b. This will not work out. It works out in the multiplication and division only, but it doesn't work out in addition and subtraction. How can we solve? We are going to learn how, but for now, please, we cannot split sums or differences. I'm going to underline it or put it in a box. Please keep in mind, we cannot split sums or differences. So let us see how can we solve the addition and subtraction of radical expressions. Let us take an example to make things clear. Suppose we have radical 3 plus 7 radical 3. The first thing you have to ask yourself, do I have the same radical in both terms? So if you can look, this is a term and this is a term. Do you have the same radical? Yes, both of them, they have radical 3. Radical 3 means 1 radical 3, okay? So this is 1 radical 3 plus 7 radical 3. So if you have the same radical, you can add the coefficients or the numbers that are before the radical. So just in case you have the same radical, okay? And now 1 plus 7 is 8 radical 3. So the final answer is 8 radical 3. Another example. 10 radical 2 minus 4 radical 2. So here you have two terms. You ask yourself, do you have the same radical? Yes, I have the same radical, which is radical 2. So I can subtract them? Yes, of course I can. So 10 minus 4 is 6 radical 2. So just to highlight things, if I have addition and subtraction of same radicals, I can add them. Else I cannot. So radical 5 plus radical 3, you cannot simplify them, you cannot add them. Why? Because you don't have the same radical. Okay? So to summarize, in addition and subtraction, if you have the same radical, you can add them or subtract them. If you don't have the same radical, you just keep them as they are, you cannot add them. Okay, now the last thing I'm going to remind you of is how to rationalize a denominator. So talking about radicals and fractions, every time you see a radical in the denominator, I need to get rid of this radical in the denominator. How? By rationalizing. What's the meaning of rationalizing? So rationalizing means to get rid of the radical in the denominator. So suppose you have, as an example, radical 3 over radical 2. So I need to get rid of radical 2 in the denominator, so I just multiply by radical 2. So multiplying both the numerator and the denominator by radical 2 will give you radical 6 in the numerator and 2 in the will give you radical 6 in the numerator and 2 in the denominator. Why? Because radical 2 times radical 2 is 2. It's radical 4, which means it's 2. Okay, so rationalizing means getting rid of the radical in the denominator, as you can see in this example. Okay, sometimes I'm going to write this for you, but of course when I come to this lesson where I need rationalizing, I will give you more examples, but I'm going to tell you this. Suppose you have for example radical 2 over radical 2 minus 1. How can I rationalize this? Of course, if you still remember, we multiply by something called the conjugate. So the conjugate of radical 2 minus 1 is radical 2 plus 1. Okay, so the conjugate, it's called the conjugate, and of course I multiply both the numerator and the denominator by this conjugate, and then I solve, as you can see, we multiply the radical 2 by both of them, and the denominator will become 2 minus 1, because if you can still remember that this is an algebraic expression, this is radical 2 minus 1 into radical 2 plus 1, this is a minus b into a plus b, which is a squared minus b squared, or in another word, if you want it more clear, this is a squared minus b squared, which means it's 2 minus 1. Okay, so if you have only a radical, as in the first example, you multiply by this radical, but if you have a term, you multiply by the conjugate of this term. Of course, if you have radical 2 minus or another denominator, radical 2 plus radical 3, you multiply by the conjugate, which is radical 2 minus radical 3. Okay, I wish everything is clear. Of course, you have a worksheet. It's a direct application of what you have learned or what we have remembered together in this video. I advise you to solve all the exercises, and of course we are going to meet tomorrow in the live session to solve some exercises. And if you have any question, of course, just write a note to solve it together, or that's everything for this lecture. Of course, the second lecture will also be revision, but about two different lessons. Good luck. That's everything.